Hello everyone and welcome to this week's OpenGL 3D game tutorial, and this week we're going to be having a look at rendering to multiple targets. So usually when we're rendering our scene we get a single result, a single 2D image of what we've rendered. Rendering to multiple targets allows us to render the scene to multiple different render buffers or textures at the same time, and we can actually render the scene slightly differently to the different buffers. So for example, one common use of this is for deferred shading, where you need to render multiple images of the scene, one showing the diffuse colours of all the objects, another showing the normals in the scene, and another showing the 3D positions of everything in the scene. These images can then be used to calculate the lighting in the scene, but that's something for a different tutorial. The point is that without rendering the scene to multiple targets, you would have to render the scene 3 times to get these 3 images. However, by rendering to multiple targets at the same time, we can carry out the rendering of the scene just once, outputting something slightly different from the fragment shaders for each target, giving us 3 different images of the scene in just a single render pass. Implementing multiple render targets is actually pretty simple. Firstly, you need to create an FBO to render the scene to, like we always do, and as usual we'll add various attachments to this FBO when we create it, such as a depth buffer attachment and a color buffer attachment. If you have a look at our previous FBO code, we've always attached the color buffer attachment as GL color attachment 0, but this week we're going to be adding another color buffer attachment to the FBO, GL color attachment 1. We then need to indicate that we want to render to both of these color buffers when we render the scene, and not just to color attachment 0. And to do this, we need to call GL draw buffers, and we need to put in the attachments that we want to render to, so GL color attachment 0 and GL color attachment 1, instead of just GL color attachment 0 as we've done previously. If we were then to go ahead and render this scene to the FBO, the scene would be rendered to both of the color buffers, giving us 2 images of the scene. Of course, having 2 identical images of the scene isn't really much use to us. We want to be able to render different things to the different buffers. For example, for the bloom effect that we were implementing last time, it would be pretty useful if we could render the normal image of the scene to one color buffer, while rendering only the bright parts of the scene that we want to glow to the other color buffer. To do this, we're going to need to have multiple output colors in our fragment shaders, one for each color buffer. That way it allows us to determine different outputs from the fragment shader for the different color buffers. However, we do of course need to tell OpenGL which output variable corresponds to which color buffer attachment, and to do this we can use the layout qualifiers like this, indicating that the usual color is going to be rendered to color attachment 0, while the bright parts of the scene are going to be rendered to color attachment 1. Using layouts like this does however require shader version 330 or higher, so if your computer doesn't support that, then you won't be able to use them. Instead, you'll need to bind your outputs to the correct color buffers by using the GL bind frag data location method in the Java code, in a very similar way to how we've been binding the inputs of the vertex shader to attributes of a VAO. Incidentally, you could actually use layouts for doing that as well if you wanted. And that is all there is to it. So just to recap, we're going to be creating an FBO. We're then going to be adding 2 color attachments instead of one as color attachment 0 and one as color attachment 1. And we're going to be using multi-sampled color buffers so that our scene is anti-aliased, and we're then going to indicate that we want to render to both of these color buffers by using the GL draw buffers method. To render to the 2 color buffers, we're then going to need to have 2 output colors in our fragment shader, which we can calculate separately to render different things to the different buffers, and we then just need to indicate which output color corresponds to which color attachment by either using layouts or by calling GL bind frag data location. If we then go ahead and render the scene, it will get rendered to the 2 color buffers here, but we have to remember that these are multi-sampled buffers, so we need to resolve them first before we can use them. So we're going to resolve each of them to a separate FBO. You could resolve them to different color attachments in the same FBO if you wanted, but there's no real advantage to doing that and it just makes the code a little bit more complicated, so we're just going to be using 2 separate FBOs. So after all that, we'll have our 2 images that we need to implement the bloom shader effect that I showed in the last tutorial, and we'll have done it without the need of the extra step to create the bright texture, plus we can now use the glow maps from 2 episodes ago to indicate which parts of the objects we want to glow. So let's jump into the code, and we're going to be starting off today in the post-processing's FBO class. And when I was planning out this tutorial, I realized that this class was very much geared towards just rendering to a single target, and so it would take quite a lot of reshuffling of this class to program it in a nice, flexible, reusable way. So for the sake of this tutorial, I'm just going to be implementing it in the quickest, easiest way that works for us, just to demonstrate the concept to you guys, and then you guys can shuffle around the FBO class to make it as flexible as you need it to be for your game. So seeing as we're always going to be using multi-sampled color buffers when we render to multiple targets, I'm just going to make it so that when you use this constructor here, it creates an FBO with 2 multi-sampled color buffers. And I'm just going to rename this boolean to make it a bit more obvious. So if this is true, we'll be using both multi-sampling and multiple render targets. So the first thing that we need to do is that when we initialize the frame buffer, we need to add 2 multi-sample color attachments if we're using multiple targets. And to do that, we're going to need to alter this create multi-sample color attachment method, because at the moment it's assuming that we're going to be attaching color attachment 0, but that's not going to be the case anymore. So we're going to take in the attachment that we want to attach, and we're going to substitute that in here. And we're also going to return an int from this method, and that's going to be the ID of the color buffer that we've created. If we then go back up to the top, we're going to need to create another int to store the ID of the second color buffer, because we're going to have 2 now. So this can be color buffer 2, and we're also going to need to remember to delete this second color buffer when the FBO is deleted. And now when we initialize the frame buffer, we can create 2 multi-sample color attachments. So color buffer is going to be equal to the multi-sample color attachment, which is going to be color attachment 0. And we're also going to want to attach a new color buffer to color attachment 1. So this is color buffer 2, and this is going to be attached to color attachment 1. So at this stage, we've got an FBO with 2 color buffer attachments, but we now need to tell OpenGL that we want to render to both of these color attachments and not just color attachment 0, which is what we're indicating at the moment by calling GL draw buffer and just putting in GL color attachment 0. So I'm going to create a new method here, which is going to determine which draw buffers we want to render to. And the method that we use to tell OpenGL is GL draw buffers, and this takes in an int buffer, and the int buffer contains the names of the attachments that we want to render to. So first we need to create the int buffer, and this is going to have a size of 2 because that's the maximum number of color buffers that we're going to be rendering to. We're always going to want to render to color attachment 0, whether we're using multiple targets or not. So we're going to put GL color attachment 0 into the int buffer. And if we're using multiple targets, then we're also going to want to render to GL color attachment 1. So we're going to put that into the int buffer as well. And once we've got all of the attachments into the int buffer, all the attachments that we want to render to, we can flip the int buffer so that it's ready for reading, and then we're going to send it off to OpenGL and tell it that those are the attachments that we want to render to. And let's now call this method instead of that GL draw buffer call. The final thing that we need to worry about in the FBO class is resolving to an FBO, because now that our FBO has 2 color buffers, we need to indicate which color buffer we actually want to resolve to this output FBO. So we're now going to take in an int, which is going to indicate which attachment we actually want to read from. And we're going to tell OpenGL that this is the attachment that we want to read from and the attachment that we want to resolve by calling GL read buffer and putting in that attachment. So that's the FBO class all done, and we can now test out these multiple render targets by going into our fragment shader for the entities, and we can now have multiple output colors, one for each of those color buffer attachments, so that we can render different things to the different attachments. And we're going to indicate here with layouts that the output called outColor is going to be rendering to color attachment 0, and the output called outBrightColor is going to be rendering to color attachment 1. And to use layouts, we need to make sure that we're using shader version 330 or higher. And if you can't do that, just keep watching, because I'll show you an alternative in a minute. We're then just going to leave the calculation for outColor as it is, and we're going to set the outBrightColor to just red. So in color attachment 0, the entity is going to look normal, but in color attachment 1, they're going to be just red. So in the main game loop, when we're resolving the FBO, we now need to choose which attachment we want to resolve. So let's start off by just resolving color attachment 0, which should have everything just looking the same because we didn't change how outColor was calculated. But if we now go and choose to resolve color attachment 1 instead, this color attachment should contain an image of the scene where all of the entities are red. And as you can see, that is the case. So in that FBO, we now have 2 color attachments with 2 different images of the scene, which were both rendered in one single render pass. So we've got the image of the scene where the entities are their normal colors, and we've got the image of the scene where, as you can see here, the entities are all red. So as I mentioned earlier, if your computer doesn't support GLSL version 330 or higher, then you won't be able to use these layouts, and instead you're going to need to indicate in a different way which output of the fragment shader should render to which color attachment. So in the shader program class, we're going to create a method that's going to do this. So this method is going to be called bind frag output. It's going to take in the int indicating which attachment we want to bind, and also the name of the output variable in the fragment shader that we want to bind it to. And the method that we need to call here is called GL bind frag data location. This takes in the shader program's ID, the attachment number, and also the output variable name in the fragment shader. So now in any of your shader program classes, you can connect up those outputs with the color buffer attachments by calling that bind frag output and putting in the attachment number and the name of that output variable. So here you can see that I'm connecting up out color to color attachment 0, and to color attachment 1 I'm going to connect up out bright color. And if you go ahead and run that, it should be working exactly the same. So you should be able to see that all of your entities are rendered in red. So now that we've got rendering to multiple targets working, we want to continue rendering the scene normally to color attachment 0, but to color attachment 1, we only want to render the bright parts of the scene because that's going to be used as the bright texture in our bloom effect. So back in the fragment shader, we're now going to properly calculate the out bright color. So first of all, let's just delete this last line where we were setting it to red. So the out bright color is usually just going to be black unless we want this fragment to be glowing. And to tell whether we want this fragment to glow, we're going to be checking the glow maps that we implemented a couple of tutorials ago. So if the glow map indicates that this part of the object should be glowing, then we're going to set the output bright color to the texture color of the object plus the specular lighting. So this is going to render to color attachment 1. So in color attachment 1, all of the objects are going to be black unless they should be glowing as indicated by the glow map. So for this to work, you will need to have an entity set up with a glow map texture, like this cube that I have here. We now just need to do a similar thing for all the other fragment shaders to indicate how these fragment shaders should be rendering to that bright map. So again, in the terrain fragment shader, I'm going to create a second output. I'm then going to indicate using layouts which color attachment these outputs should be rendering to, and of course make sure that you're using version 330 if you're going to use that method. And I'm then just going to set out bright color to black because obviously I don't want my terrain to be glowing, so I don't want it to be rendered to the glow map. And if I run that, you can see that the terrain is now appearing black. And you now just need to do the exact same thing in your water fragment shader and also in your normal map fragment shader. So now everything that gets rendered to your bright texture should be black, except for the parts that you want to glow. So for me, that's the sky, and also any parts of entities that have been indicated to be glowing by the glow maps. So now that we've created our bright texture, we can go into our post-processing class, and the do post-processing method can now take in that bright texture, and we can now skip the bright filter stage, which was previously creating the bright texture, and we can just put the bright texture straight in to the Gaussian blur part. So let's go back into the main game loop. In here at the moment we're only resolving color attachment 1, and we're resolving that to output FBO, so we now need to create a second FBO so that we can resolve both of those color attachments. So this is going to be output FBO 2, and let's remember to clean this up when the game closes. So we're going to resolve color attachment 0 to output FBO, and we're going to also want to resolve color attachment 1, which contains the bright texture, to output FBO 2. And finally, into our do post-processing method, we put the color texture of the scene, which is in output FBO, and we put the bright texture, which is in output FBO 2. So if we go ahead and run that, it should all now be working, and any parts of the objects that you've indicated to glow using the glow maps should now be glowing, and you can see that that's working for me here on this cube. And you can see that the sky is also glowing for me because I also rendered the sky to the bright texture. And of course you don't have to use the glow maps if you don't want to. You can render whatever you want to the bright texture. It's just whatever you set that out bright color to in the fragment shaders. So you could use the calculations that we used last week, or you could use something else. It's totally up to you how you decide to create that bright texture. So that is going to be it for this week. Thank you guys very much for watching this video. Do subscribe if you haven't already. Have a fantastic week, and I will see you all next time.